Welcome to the lesson on the analyze phase of the Six Sigma DM-AIC model. Upon completion of this lesson, learners will be able to explain the analyze phase and recognize the tools associated with the analyze phase of the DM-AIC model. Collecting data is an important step in the DM-AIC process. However, data does not provide in-depth information about the system until it is analyzed. After collecting data, Six Sigma project teams are sometimes tempted to jump straight to solutions. There is an impulse to immediately fix the problems based on preconceived ideas. This kind of thinking can cause problems for the project team because the analysis step exposes findings that would have otherwise been overlooked. Thorough data analysis is needed to determine what the data actually says about the company's production processes. The purpose of the analyze phase is to decode the collected data and find the root causes or sources of variations and defects. In other words, it's time to hunt down and verify the root of the problems. Before any analysis tools are used, the team should brainstorm and generate ideas about the sources of defects. Then, the team can use a number of tools to prioritize and verify their hypotheses about the causes of defects. The analyze phase of the project will be unsuccessful unless the team lets the data lead the way. The analysis tools described in this lesson have been grouped into the following categories: brainstorming and uncovering root causes, graphical analysis, statistical analysis, and verifying root causes. Brainstorming is an important step in analyzing production problems because it encourages team members to develop outside-the-box ideas without the risk of criticism from other team members. Affinity diagrams are used in the brainstorming process to help generate, display, organize, and categorize ideas. It is important that the team stays focused on ideas for possible causes of defects instead of trying to find a solution. A fishbone diagram, also called a cause and effect diagram, is a brainstorming and analysis tool that helps identify all root causes of a defect by mapping possible causes and their given effects. The head of the fish is the defect or problem under investigation. The bones of the fish are possible causes of the defect. These diagrams can categorize causes in a number of ways, but generally they're categorized by either function or sequence. Another common way to categorize is by the 6 M's we mentioned earlier: machine, manpower, material, method, measurement, and Mother Nature. Fishbone diagrams take large problems and divide them into more manageable ones, which make them one of the most commonly used quality improvement tool. One downfall of the fishbone diagram is that it does not provide an importance weight of the factors on the end effect. A 5 whys diagram, or a YY diagram, is a systematic tool used to brainstorm and identify root causes by asking why 5 times consecutively until the heart of the problem is exposed. Using the 5 whys to solve a problem is best when numerical data is hard to find. In the diagram here, begin by asking why a main problem exists. Then ask why that next problem exists, and so on, until the root causes are identified. Typically, 5 levels of asking why is sufficient to determining a potential root cause of the problem. This image shows a template for how to perform 5 whys analysis. Let us examine an example of a 5 why analysis in a battery electric vehicle factory. The problem is a delay in EV battery installation on the assembly line. By repeatedly asking why, then we uncover that batteries aren't arriving on time due to delays in internal transport. This is caused by electric forklifts being unavailable, which stems from them frequently being out of charge. The final why reveals that there's no standardized process for recharging forklifts between shifts. Thus, the root cause is identified as a lack of a systematic battery management system for support equipment. This demonstrates how the 5 why technique can reveal underlying issues that may not be immediately apparent, allowing for more effective problem solving. Graphical analysis provides clear visual representation of the relationships and patterns in the data. Graphical analysis is often used to identify areas that may require further analysis. A Pareto chart is a special bar chart that prioritizes the sources of problems. Pareto charts show the potential factors that are causing a certain event and account of the number of times that the given event was caused by each factor. This means that factors, or potential sources of problems, are ranked based on the number of times that they attributed to the problem. Pareto charts are useful because they allow the team to focus their efforts on larger contributors of problems instead of minor ones. This Pareto chart that you see here has 6 causes. The data points that are connected by the orange line represent the cumulative percent of the causes on the effect. The dashed line represents the point of significance. Any causes that exceed this dashed line are considered a significant cause. A histogram is useful in analyzing continuous data because it shows the frequency and distribution of events, which then reveals the amount of variation in a given process. Histograms clearly mark the target value, the distribution of the data, and the data's central tendencies. Furthermore, histograms provide insight on the amount and type of variation within a process. A normal or bell-shaped curve is an indicator of common cause variation. The histogram shown in here uses a discrete tally of the frequency of events and illustrates a normal distribution curve. By looking at the histogram, we can estimate that the central tendency is somewhere in the 11-15 bin range. Another graphical tool, scatter plots are a valuable tool in data analysis, particularly for visualizing the relationship between two variables. These graphical representations help identify potential cause and effect relationships between process, inputs, and outputs, making them especially useful in the analyze phase. By plotting data points on a two-dimensional graph, scatter plots reveal the strength, direction, and nature of correlations between variables. They can show whether a relationship is positive, that is, the variables increase together, or negative, meaning as one variable increases, the other decreases. They can also show whether it's linear, curvilinear, or if there's no discernible relationship at all between the variables. This visual insight allows analysts to quickly grasp complex data patterns, guiding further investigation and statistical analysis in process improvement efforts. A run chart is a graphical tool that logs an event over time, making the detection of time-related trends and patterns easier. A run chart is a simple line graph used for continuous data. If a trend or shift is found, the data may call for further analysis, such as regression analysis. Now, moving from graphic analysis tools, we will take a look at statistical analysis tools. Statistical analysis is often the more complicated method of analysis because it may call for special computer programs and math-intensive formulas. Statistical analysis often takes a narrowed set of possible defect sources and tests them further. It also is used to verify root causes suggested in earlier analysis. Regression analysis is a method of curve fitting for data that finds the best fit for the relationship between two variables. Although regression analysis can be done by hand, it is usually run on basic software like Excel or another program. The software gives an R-squared value between 0 and 1, which represents how closely the variables are related. If the R-squared value is greater than 0.8, the correlation is considered strong. In the scatter plot example in the previous slide, the R-squared value is 0.936, therefore, there is a strong correlation between cause and effect. Regression analysis is used to confirm that a cause and effect are related, either negatively or positively. It is important to remember that a relationship between variables does not mean that one variable causes the other. If trends or patterns cannot be detected in graphical analysis, or the data trends need to be verified, the project team can use tests of statistical significance to validate or disprove their hypothesis. Tests of statistical significance are math-intensive and should be conducted by someone with experience either by hand or using a computer. For this reason, tests like ANOVA, t-tests, and chi-squared tests will not be presented in detail. The important thing for members of the project to know is why these tests are needed. These tests can be used to validate or disprove patterns, trends, and relationships in the data. ANOVA, also known as analysis of variance, compares data from multiple groups to determine which groups are statistically different from one another. T-tests compare means between two groups to determine if they are significantly different. Chi-square tests assess whether there is a significant association between categorical variables. By employing these statistical tools, project teams can make data-driven decisions and draw reliable conclusions from their analyses. Here are a few examples that aim to explain the significance of the analysis tools in an EV factory setting. ANOVA can be employed to verify if different environmental conditions, such as temperature and humidity, significantly affect battery performance, or to determine if multiple assembly line configurations have significantly different throughput rates. T-tests are useful for confirming whether a new welding technique reduces joint failures, or for evaluating if there is a significant difference in energy consumption between two motor designs. Chi-square tests can be utilized for analyzing if there's an association between shift times and defect rates, or for examining if there is a relationship between battery cell supplier and failure rates. These examples demonstrate how statistical tools can provide valuable insights into various aspects of automotive manufacturing, from production processes to quality control, enabling data-driven decision-making and continuous improvement. The deliverables of the analyze step are a verified set of root causes of variation and a prioritized list of the opportunities to improve. With the wide range of analysis tools available at our fingertips, it is important for the team to choose methods that are appropriate for their data. The analysis step is all about letting the data lead the way. In summary, the analyze phase of the DMAIC model utilizes the data collected in the measure phase to detect root causes or source of variation and defects in the production process. Tools in the analyze phase include affinity diagrams, fishbone diagrams, 5Y diagrams, Pareto charts, histograms, scatter plots, and run charts. In addition, statistical analysis may also be used in the analyze phase and include tools like regression analysis and tests of statistical significance. Thank you.